So, as I said, inverters take a lot of load. How do you charge your batteries? The problem with batteries is you have to keep them charged. I told you they don't have that much power. There's multiple ways to charge a battery. Most RVs come with a converter. Converters come in all descriptions. Junky converters, which a lot of RV manufacturers put in, only put out about a 10 amp trickle charge charger. And they convert your shore power to 12 volt and charge your battery at the same time at 10 amps. So I told you before, if you're running your furnace, that can be running more than 10 amps. So your battery will still drain down a little bit with a 10 amp charger on the converter. If you run your furnace overnight, it probably will not be dead. It just will not be in full when you're done. And it's also, they don't have a good charging circuit. They just have a simplistic charging circuit that just kind of puts something like 13.8 or 13.9 volts into it. And that just isn't enough to really make a battery happy. Alternator does a little better. If you have it plugged into your truck engine through a cable, but often those cables don't have a big enough wire. They're more like a trickle charger also, because they just don't have enough coming from the alternator. On motorhomes, often the motorhome engine is hooked up, but it's got a little bit of wiring most of the time, but it still isn't optimal charger. So you can buy better converters, or you can find out if you have one, that have a 40 to 80 amp charger in them that's got 3-stage charging, which does the right thing. And it's really nice if you get one that you can actually configure. If you've got 8 different kind of batteries, you can vary the characteristics. Makes it a interesting problem to figure out how to get it to charge. So you've got the alternator on the engine, you've got a converter, and then they make something called an inverter charger. An inverter, I told you, just inverts, but they also make these big things. And some people who have big RVs when they talk about their inverter, they really have an inverter charger. Inverter charger is it's normally a 2,000 watt or 3,000 or 4,000 watt inverter that also has a charging circuit built in it. These chargers are normally very, very good. They put the money into them, they put the electronics into them, they normally have a very good interface where you can program them for not just type of battery, but sometimes brand. And or you can get charts from your actual battery manufacturer and configure it perfectly. And you can put a temperature compensation probe in, so the charger will vary based on how warm the battery is, because most batteries charge differently if they're 30 degrees outside or 90 degrees outside. And when they're 90 degrees, they don't put as many volts out. When they're 30 degrees, they can put a lot of volts out, which is where some people have actually caused issues. They've gone out in the freezing weather, their RV, and the batteries are out where they're exposed to cold, and their charger kicks on and is taking them up to 15 volts, and lights are popping. Some of the early LED lights were really bad this way, and they have cheap inverters that just scale. And suddenly, instead of putting 120 volts, they're putting 135, 140 volts, because they're getting 15 volts input. And televisions go pop and stuff. It's not a real problem, just keep it in mind. It's real. So, inverters, batteries, converters, and then let's talk about solar. Solar panels. Sounds wonderful. Solar panels come in a variety of types. Normally there's 2 different kinds of rigid ones. One kind is really just simplistic little thing, and the other one's a little more constrained, which has cells. It puts out. You normally want a good solar charge controller. A good charge controller will take, if the panel is putting out 18 volts, it will not just convert it to 13.5 volts. It will boost a little bit of the amps to take that 18 volts to 13.5 and gives you a little bit more charging power. But you know, when you've got a 100-watt solar panel laying flat on the roof in the wintertime, it's only going to be putting out at best around 60 watts for about 5 hours. If you tilt it so that it points straight to the sun, you'll get about close to 100 watts for about 5 hours. But it has to be pointed right at the sun. So when you run your solar panels, you don't get what they rated. And you don't get it all day. You don't get it when the sun's shining. You get it when it's close to noon. So a 100-watt panel times 5 is 500 watt hours. Divide that by 12, you're running around 40 amp hours, or about what you need to charge one battery that's been drained. So every battery you get, and I'm talking the batteries that are kind of the car size, you need a 130 watt solar panel. So you get a 250 watt solar panel, you can charge 2 batteries if the sun is out and you're pointing it properly. If you're laying it flat on the roof, you're going to need 350, 400 watts to charge 2 batteries that are drained overnight, fully drained. So that tells you, plus if you get a cheap charge controller, it doesn't do nearly as good a job. You need a really good charge controller, and you're talking $150 for a decent one and $300 to $800 depending on how much you want to put into it for a really good one. Panels are pretty cheap right now, but they don't do everything. Flexible panels don't wear as well. They're kind of a nice idea, but people have found that if you glue them to the RV roof, they cup on you because the RV roof gets hot. It's very hot in the sun, and they end up warping and not working as well. So you need to put them on. There's how much they weigh, how do you want to move them around. Solar panels can be a real mess. Wind generators. Wind generators sound so good, but if you look at wind generators, they normally need about a 12 to 15 mile an hour wind to really even do anything. I don't like to be in 12 and 15 mile an hour wind. Plus they want them up 25, 30 foot in the air. So you have to carry a pole, a rigid pole setup, a telescoping pole that can put the wind generator up 25 feet in the air. And if it's not very rigid, it'll warp and wobble. And then the big issue is it makes noise. So if you attach it to your ladder on the back of your RV, you're going to hear this noise at 3 in the morning when it's running. Your neighbors are going to hear that noise because it's not just going to be in your RV. That's why a lot of people don't use wind. Wind night's a nice, stable, static pole where the wind is blowing at a reasonable, more than most people are comfortable with. More than a breeze. You want wind. That's how you charge batteries. You want to charge batteries? You got solar. That's great unless it's cloudy. But you need enough solar panels. I told you that they're going to generate, each panel is going to generate, probably something closer to 80% of what they say. So if you put 1,000 watts of solar panels on your roof, which sounds like a lot, you're going to get 800 watts of power coming out of it. An air conditioner is going to want 1,500 watts. So if you run your air conditioner while pulling in 800 watts of solar, you're going to be at a deficit of 700 watts air and draining your batteries as you go. If your air conditioner is hooked up to an inverter at all, to your batteries at all. So people like to show little videos where they run their air conditioner for a little bit, but they don't run them as much as they really say. They'll run them for an hour, cool themselves down. Or they're running a small air conditioner, like a 700 watt air conditioner, and they're not and they're driving their little van around or something. They're not sitting out in the middle of nowhere in quartzite, running on and in the desert, running a air conditioner for hours and hours and off their batteries. You can run it for a little while. You can't run it for a lot. This batteries, electricity, it's all a very complicated problem. The big getaways is that batteries are not that big. Don't mix up the amps between a 12-volt battery and a 120, because a 12-volt battery's amps are 100 amps of 12-volt battery is 10 amps of, 1 amp of 1 amp of 120 volt is 10 amps of the battery. So if those are real loads. Things happen. Interesting things go on. The other, I'll take a couple odd subjects now. You want to run a little generator, a 1,000-watt generator, to charge your batteries. Well, they normally come with a charger, but it's normally not a very good charger. They normally expect you to hook it up to your converter or your inverter charger. You want that converter or inverter charger to be able to be programmed to so you can start with 100,000 watts. Because if the charger wants 1,500 or 2,000 watts coming in, the generator will stall. I know people who've done this and complained and gotten crazy, but it's true. That's a side thing. Small generators, you have to have a programmable charger. Just a little piece of knowledge to have. Thanks, I'm sure I've caused more questions than answers, but it's a crazy subject.